In this module, we are going to discuss the fundamentals of volumetric analysis. Volumetric analysis. Volumetric analysis is a quantitative analytical method. As the name implies, this method involves the measurement of volume of a solution of known concentration, which is used to determine the concentration of the analyte. The terms used in volumetric analysis are titrant or titrator, titrant or analyte, titer, titration point, indicator, equivalence point, endpoint, standard solution, concentration, normality, molality and molarity. Titrant or titrator. The solution of known concentration that is added to another solution in order to determine the concentration of the another solution is called titrant. Analyte or titrant. The solution whose concentration to be estimated is taken in the conical flask is known as titrant or analyte. Equivalence point. The equivalence point or stoichiometric point is the point in a titration where the amount of titrant added is enough to completely neutralize the analyte solution. At equivalence point, the moles of titrant equal to the moles of the solution with unknown concentration. Endpoint. It is a stage at which the observed reaction is completed. Endpoint is observed with the help of indicator. Indicator. It is a complex organic compound which shows the clear visual change after the reaction between analyte and titrant is just complete. An indicator is chosen in a particular titration based on the pH range of the indicator and the pH change near the equivalence point. Titer. The measured volume of titrant delivered from the burette to reach the endpoint of the titration. Titration. The process of addition of standard solution from burette into the solution of unknown concentration taken in the conical flask is known as titration. Titration error. The stage during the titration at which exactly equivalent amount of titrant is added to titrant is known as equivalence point. In theoretical concept, when equivalent amount of titrant is added to the titrant, the indicator should change the color and indicate the endpoint. But in actual practice, the indicator does not change its color at equivalence point. This is because the indicator changes its color either in acidic or alkaline medium. Therefore, in practice, a small difference occurs between equivalence point and endpoint. This difference in volume between the equivalence point and the endpoint is the titration error. Example. Suppose experimental value is 5.10, actual value is 5. Then error is equal to experimental value minus actual value divided by actual value. Standardization. A process to determine the concentration of a solution of known concentration by titrating with a primary standard is called Standardization. Standard solution. A solution of accurately known strength is known as standard solution. It is prepared by dissolving a accurately weighed quantity of highly pure material called primary standard and diluted to an exact known volume. Standard solutions are usually expressed in terms of molarity or normality. Primary standard solution. The substance whose standard solution can be prepared directly by dissolving the known weight of the substance in fixed volume of the solution is known as primary standard substance. Anhydrous sodium carbonate, oxalic acid, silver nitrate can be used as primary standard substance. The solution of primary standard substance is known as primary standard solution. A good primary standard substance has a high level of purity. It is non-toxic. It is not likely to absorb the moisture from the air to reduce changes in mass. It has a high equivalent weight to reduce error from mass measurements. It should be readily dissolved in water. It should be stable. In other words, the composition of the substance should not change in solid or in solution state for a long time. Secondary standard solution. The substance whose solution can be standardized or strength can be determined by the help of primary standard solution is known as secondary standard substance, and the solution is known as secondary standard solution. NaOH, HCl, KMnO4, FeSO4 can be used as secondary standard substance. Volumetric analysis is based on the law of chemical equivalent, which states that the substance react in the proportion of their equivalent weights. That is, 1 gram equivalent of acid will neutralize by 1 gram equivalent of the base. Concentration of a solute in a solution is defined as the quantity of solute dissolved in unit quantity of a solvent. There are many ways of expressing the concentration of the solution. Percentage by weight, percentage by volume, weight by volume, mole fraction, parts per million, molarity, molality, and normality. Normality is described as the number of gram or mole equivalents of solute present in 1 liter of a solution. Number of gram equivalent of solute is equal to mass of solute in gram divided by equivalent weight of solute. Molarity. Molarity of any solution is number of moles of solute per liter of solution. It is indicated by uppercase M. Molality. Molality of any solution is represented as the number of moles of solute present per kilogram of solvent. It is indicated by lowercase m. Volumetric analysis can be classified into 4 types: acid-base titration, redox titration, precipitation titration, complexometric titration. Acid-base titration. It is a quantitative analysis method to determine an acid or base concentration by precisely neutralizing them with a standard solution of either acid or base of known concentration. Acid-base reactions involve combination of hydrogen and hydroxide ion to form water. Redox titration. The redox titration is also known as oxidation reduction titration. In this type of titration, the chemical reaction takes place with the transfer of electrons in the reacting ions of aqueous solutions. The titrations are named after the reagent that is used in the titrations. Example, permanganate titrations, dichromate titrations, iodometric and iodometric titrations. Permanganate titrations. Potassium permanganate is an oxidizing agent in this kind of redox titration method. It works in acidic medium more strongly than alkaline medium. So far in qualitative analysis, potassium permanganate is generally used in acidic medium only. The addition of sulfuric acid helps to raise the hydrogen ions present in the solution. The solution which contains permanganate ion, it is purple in color, while the solution containing manganese ions is colorless. In this method, the reagent has strong color because of the permanganate ion. Thus KMnO4, when reacts with the reducing agent, it works as self-indicator also. The potassium permanganate titration helps in the estimation of ferrous salts, hydrogen peroxide, oxalic acid, oxalate and more still. Dichromate titrations. In this technique, potassium dichromate behaves as the oxidant in the acidic medium. It is essential to maintain the acidity of the medium by the addition of dilute sulfuric acid. Dichromate ion is not a self-indicator. Still, dichromate ion oxidizes the indicator diphenylamine after achieving the equivalence point, thereby making an intense blue color. We can use the potassium dichromate in titrations directly. This technique helps in the estimation of ferrous salts and iodides. Iodometric and iodometric titrations. Iodometric titrations are used to quantify oxidizing agents. In this type of titration, the species whose quantity is to be determined is titrated with iodine solution. In the reaction, iodide gets converted into iodine and then the released iodine is titrated with standard thiosulfate. So it is an indirect method. Iodometric titrations are used to quantify reducing agents. In this type of titration, the species whose quantity is to be determined is titrated with iodine. In the reaction, iodine gets converted into iodide, which can be detected using starch solution as indicator. So it is a direct method. Precipitation titration. Precipitation titration involves the formation of precipitate during the course of titration. The titrant reacts with the analyte forming an insoluble material and the titration continues till the very last amount of analyte is consumed. The first drop of titrant in excess will react with an indicator resulting in a color change and indicating the completion of the titration. Complexometric titration. In complexometric titration, the endpoint is indicated by a colored complex. It is also known as kinetometry. Complexometric titrations are used for the determination of concentration of metal ions in solution. Complexometric indicators undergo a definite color change in the presence of a specific metal ion. These indicators, also known as PM indicator or metallochromic indicators.